Hello, let's do some curve sketching practice. So I'll start off with r is equal to sine 2 theta. Our strategy here is first going to be to graph this as if it was just an xy coordinate graph, and then translate that into our polar axes. So sine 2 theta is similar to sine theta, except that the period is now pi instead of 2 pi. So sine usually starts down here. Good enough. So that's one period, that's two period. The intersection's at pi, this one's at 2 pi. Okay, so this high point happens when theta is pi over 4. So this gives us the point. Now here I'm going to give all my points as r theta coordinates just to kind of get used to that system. But like I said in class, you can translate to xy coordinates if that helps you. Okay, so here we've got the point in terms of r theta, 1 pi over 4. This one down here is -1, 3 pi over 4. But because we are in a polar coordinate system, we can switch this to positive radius by adding or subtracting pi from the angle part. So here I'm going to subtract just to make it negative pi over 4. Let's see, let's get some other points. This one happens at 5 pi over 4. And then this one is -1, 7 pi over 4, which again, we can use the same sort of trick. And we get that this is 1, 3 pi over 4. Okay, so we can start sketching this out now. We'll see that the radius is never anything greater than 1. So what I'm going to do is, because we don't really have axes in the same way, we can actually sketch out references for different radii. So let's say that this is the radius is equal to 1 circle. And so this can help us place some points. So we know that when the theta here is 0, we get this point at 0, 0. Then when our angle is pi over 4, we've got this radius of 1. So that means that we land on that radius 1 circle when theta is pi over 4. So that's what this point is. Then our graph is going to go back to the origin. But I'll be marking out some other kind of intermediate points along the way, but I just want to put down these main ones first. Okay, and then we saw that, actually, yeah, what I'll do is I'll kind of give us an idea of where we go. Okay, then we go back to the origin, and then we go to that point that was 1, negative pi over 4. So that's this one. So we're going to have to go out here somehow. And then we go back to the origin at pi. Then our graph is going to go to 1, 5 pi over 4. So that's this one here. Oops. And again, here I'm using this radius 1 circle as reference to place these points. So we're going to go out here, then back again at that 3 pi over 2. And then at 3 pi over 4, we've got another one with radius 1. And then it's going to go back out and all that. Okay, and then if we want to be more precise and see exactly how we get to these endpoints on the r is equal to 1 circle, we can just check some other values in the graph. So for instance, here, let's say we check pi over 6 when theta is equal to pi over 6, r is equal to, so sine of pi over 3, which is root 3 over 2, and let's place that somewhere. So that would be like here. And in fact, what we can do, let's get like another color going. We can make like a circle that's for r is equal to root 3 over 2, because we're going to have a lot of points actually that end up landing there. Okay, and then let's see what we get in this area here. So that would mean looking at angles between pi over 4 and pi over 2. So we could say, oops, pi over 3. So when theta is equal to pi over 3, r is sine 2 pi over 3, which again is root 3 over 2. So that's how we get then this point here. And so then now we're able to see how our curve traces through what's going on in order. So we start at 0, 0. Then we go through this point at pi over 6. Then through this point at pi over 4. Then this point at pi over 3. And then back here. And then I won't go through the whole graph, but we can keep doing this. We can keep finding more points. So if we know that next we're going to be going in quadrant 4, let's see some points that will guide us towards how we do that. So for instance, let's take some angle that's between pi over 2 and 3 pi over 4. So that could be like 2 pi over 3. So theta is equal to 2 pi over 3. We get r equal to sine 4 pi over 3, which should be negative root 3 over 2. And so that negative root 3 over 2, 2 pi over 3, again, we can use that trick where we make our radius positive again and add or subtract pi. And I'll subtract, and just call this negative pi over 3. And then that's how we get another point on that radius, root 3 over 2, for negative pi over 3. So that would be, let's say, right here. And so then we can see that if our curve starts off like this, let's say that's the first segment, this is the second segment, then we're going to go like this in the third segment. And so on. So what we can keep doing is choosing these angles that are like 2 pi over 3, pi over 6, those ones that are like in between all of the multiples of pi over 4 and pi over 2, and get the rest of them. So I guess if you want to complete this one fully, you can also check theta equals to, so okay, let's see, we've got 5 pi over 6 to look at, 7 pi over 6, okay, 8 pi over 6, which is 4 pi over 3, I've got to look at. 9 pi over 6, which is 3 pi over 2, we got that one. Then 10 pi over, well, anyways, let's check all of those. So this one was 5 pi over 3. Or wait, no, shoot. Okay, sorry. Doing this all live is maybe. Okay, so this is 11 pi over 6. So we'll have to do that one. Okay, then we did 5 pi over, okay, we'll have 10 pi over, whatever. It's just all the multiples of pi over 6. So 5 pi over 3. And then I guess we're maybe 10, 9. I guess that's all of them. And the end result is that you're going to get rows with 4 petals, which is exactly what you would expect by looking at this equation, because here, this coefficient here is 2, and whenever we have something that's kind of this form, where it's sine some constant n times theta or cos some constant n times theta, when that n is even, we get 2 n petals. But I'm going to try to sketch all of these without knowing anything about the equation, because, you know, you want to be able to sketch them whether or not you know what to expect. And so then once you do the rest of it, then you get going through here. Oops. It should go like that. Okay. Now we're going to look at r is equal to 3 sine theta. So again, I'm going to start off with the graph of r is equal to 3 sine theta, just like this. So 3 sine theta means that we're going to have high of 3 and a low of negative 3. And the period is just 2 pi. So something like that. Go through here at pi. And let's get ourselves some points. Also gonna, this is our like polar axis. Okay, so here we've got 0, 0. So that's why I've got this one here. This high point happens when theta is pi over 2. And so then that corresponds to the point 3 pi over 2. And so that means then that when we've got a radius of 3 at the angle pi over 2. So I'm going to do the same thing again where I kind of traced out these circles showing like the different radii, because I actually think that's kind of helpful. And I think when you do sketching like this on Desmos, they include those, and I think it's actually kind of nice to see. Of course, these are kind of rough sketches, but hopefully it shows sort of the strategy and intuition. Anyways, okay, so pi over 2, we get 3. That's this point. And then this is one of those ones where in the last half of the graph, we kind of just get a lot of the same points. So for instance, this one down here, this is 3 pi over 2. We've got a radius of negative 3, but that's the same as just 3 pi over 2. And so what we're going to have to do to get more like actual information is to look at some of the intermediate angles within our graph. So let's start doing that. So let's say we look at pi over 4. This is going to be at 3 root 2 over 2. So what is 3 root 2 over 2? Some number. I'll get what it is so I can just place it properly between what we've got. Okay, that's like 2 point something. If I didn't have those r's equal to 1 and 2 lines, then it wouldn't matter as much, but now I want to do it properly. Okay, so I've got 3 root 2 over 2 pi over 4. So now at pi over 4, we're going to have a point that's like right here. Okay. Now let's do some more angles that are kind of in between. So here, let's say we're doing pi over 6, and let's also do pi over 3. So r is equal to 3 sine pi over 6. Then that means that at pi over 6, we get r is 3 over 2. So at 1.5, so that would be like right here, because we're halfway between the 1 and 2 lines. And let's also do pi over 3. So that's 3 root 3 over 2, whatever that number is. It's going to be greater than root 2 over 2. So it'll be like this. So now we can kind of see that our curve is going like that. And then if we looked at more of the angles between pi over 2 and pi, so let's say theta is equal to 2 pi over 3. We could look at 3 pi over 4 and 5 pi over 6 to get these points. It'll look like this. We've kind of got a symmetry here even. And that would give us the rest of this circle. And yeah, so in fact, this is a circle of radius 3 over 2. Yeah. So again, I guess a lot of these, I'm starting off just by plotting some of the most basic angles and then trying to find ones in between that will help me to sketch what's going on. Okay, then we've got r is equal to 1 sine theta, or 1 plus sine theta. Okay, let's look at our graph again. So if this is theta, this is r. 1 plus sine theta just means that we take the usual sine theta graph and move it up by 1. So instead of starting at 0, we start at 1. Oops, that's a disaster. Okay, there we go. And so let's say that's at 2 pi. So then this would be at pi. Okay, let's start getting ourselves some points. This low point will actually be at 0. It's at 3 pi over 2. Here we've got a high point at pi over 2, and the radius will be 2. I'll start actually writing out these points. So we have when theta is 0, oops, other way around. Okay, when theta is 0, r is 1. Then we have that when theta is pi over 2, r is 2. Then we have a radius of 1 again at pi. We have a radius at 0 at 3 pi over 2. And then at 2 pi we get back to that 1, 0. So if you try sketching this out, and I'm going to do those radius circles again because those are actually kind of cool. So let's say this is going to be the radius 1 circle. And these are just kind of to guide us as we're sketching. Okay, so we've got that point. So when theta is 0, r is 1. That's this. Then when theta is pi over 2, r is 2. So that goes up here. Then when theta is pi, we've got r is 1 again. And then when theta is 3 pi over 2, we get a point at the origin. Great. Now let's get ourselves some in-between angles to kind of help sketch what's going on. So let's say we look at, again, like pi over 6, pi over 3. We could look at pi over 4 as well. But let's start with those two. Okay, so when theta is equal to pi over 6, r is going to be equal to 1 plus 1/2. So that means that we're halfway between those two radius circles. So when theta is pi over 6, we get a point like right here. Then when theta is equal to pi over 3, we'll have r equal to 1 plus root 3 over 2. So whatever that number is, that will be like right here. Good enough. And so then we can kind of see that we start here. We kind of trace out like that. And then if we also get the points for I guess 2 pi over 3. We'll also get the same R value here because of the symmetry of cosine and sine means that a lot of these shapes end up having some symmetry. So that one's right there. When theta is pi over 6, R is going to be 3 over 2 again. And so then that's how we get here. Then what happens at this bottom part, let's check some angles like, let's say 5 pi over, or not 5 pi over 6, that would be 7 pi over 6. And let's also check 11 pi over 6. Here we'll actually get R is equal to 1/2, and same at 11 pi over 6. Because normally sine is negative 1/2 there, so we just add 1. So that means then we get those points. So 5 pi over 6, 11 pi over 6. Oh, I made those too far out. Okay. So it's only a radius of 1/2. So it's halfway to that radius is equal to 1 circle. And that's how we end up getting this cardioid. And again, we can, choose more points and plot all of them, but I'm just, again, strategically choosing ones between some of the usual, like, I guess, checkpoints kind of, just to kind of get a sense of the curve. Cool. All right, now R is equal to 4 cos 3 theta. So 3 theta means that our period now, instead of being 2 pi, is 2 pi over 3. And also the 4 in front, okay, I'll write that out. Okay, so period is going to be 2 pi over 3. And this 4 means that the amplitude is 4. So if we're just sketching this out like a normal rectangular coordinates, we'll start up here. Go down, the lowest is there. And then 1, 2, 3. Oh, did I do too many? Oh, that's good. Okay. So this is at 2 pi over 3. This one's at 4 pi over 3. And then this one's at 6 pi over 3, aka 2 pi. Okay, and then we've got a low point here. And this is going to be at pi over 3. This one is at 3 pi over 3, so just pi. And then this one is at 5 pi over 3. So if we start to plot this out, so this is radius 1, radius 2, radius 3, radius, oh geez, okay, radius 4, let's say. Then, okay, we've got this here. Then at pi over 3, we'll get the point negative 4 pi over 3, which is equivalent to radius of 4 at the angle 4 pi over 3. So that would mean down here. Then this at 2 pi over 3, you can just plot normally. And then this one at pi, negative 4 pi is the same thing as 4 at 0 or 2 pi. So now we're just kind of going back to these, I guess, tips of the petals. This is going to be a rose. And then we'll have to find some kind of in-between angles. This one's a little awkward with the 3 pi, I guess, but you know, it is what it is. Okay, so let's say we're gonna do theta is equal to pi over 6. Oh, no, that'll be 0. Okay. Well, I have to do even smaller angles. So let's say we do theta is equal to pi over 9. Then r is equal to 4 times cos pi over 3, which is just 1/2. So we get 4 over 2, so we get 2. So at this really small angle, we're going to have this radius of 2. Okay, so you can see that we'll start out there, and then it's going to come back in. Then let's choose an angle that's after we come back in. So that means we want an angle between, okay, so if this was at pi over 6, here we were just looking at like pi over 9. Let's see. Do 2 pi over 9. And I'll do another color again just to kind of make it easier to see. So 2 pi over 9 should be there. So when theta is equal to 2 pi over 9, r is going to be 4 times cos 2 pi over 3. So 4 times negative 1/2, so negative 2. That gives us the point negative 2, 2 pi over 9, which is the same as 2. And then I can go either plus or minus pi to this. And I'm going to go plus, so we have 11 pi over 9, which is just 2 pi over 9 more than pi. So if this here is the angle pi, then our 11 pi over 9, let's do a radius of 2, kind of over here. So then we'll go like this. And then we can keep doing that and checking these kind of check multiples of pi over 9. We'll see that we kind of keep going like that, and then like this, and then like this. So this is a rose with 3 petals. Oops. And it goes like that. And the cos 3 theta would just have the peak be when radius is 1. But now, because we've got the 4 in front, it just means that the tip are at, the tips are when radius is 4. So there's that one. I think I mentioned in class that whenever you have a rose that has cos, you'll always have, so like if it's r is equal to c cos n theta, you'll always have a tip of a petal at C, and then when the angle is 0. So that's this first one here. So that might help if you're able to recognize that. And then the tips of the other petals are just going to be evenly distributed over the next 2 pi. Cool. Okay, let's do this next one. We've got r is equal to 1 minus cos theta. So let's get our graph going. 1 minus cos theta, that one is like we flip cos theta over the x-axis, and then we add 1 to it. And so if we kind of just think about what some of the angles would be, when theta is 0, we'll get that r is 0 because we have 1 minus 1. And then when theta is pi over 2, we get r is 1. So if we're trying to divide this up into our usual single period, let's say, so we have 0, 0. then we're going to have a radius of 1 at pi over 2. And then we're going to end up having, so when theta is equal to pi, radius is 2. Then we're going to go back down, and then back down. So this graph looks like this. Okay. So we can start putting in some of these points already. So we have this one at 0, 0. Then we have a radius of 1. And I'm going to do these circles again. So we have a radius of 1 at pi over 2, then a radius of 2 at pi. Oops. 1 pi over 2. And then a radius of 1 again at 3 pi over 2. Okay. And then now again, we're going to want to choose some in-between angles. So let's say we do pi over 3. Then r is going to be 1 minus cosine of pi over 3, which is 1/2, so 1/2. So then that means we've got this point with radius of 1/2 at the angle theta is equal to pi over 3. So at pi over 3, we get this radius of 1/2. So it's halfway between the origin and that radius of 1 circle. So that tells us now we're going to go like this. And then let's do some angle that's between pi over 2 and pi to kind of guide us in going over there. Let's say we do, I don't know, let's do 2 pi over 3. I'm just kind of choosing the pi over 3 and pi over 6 angles because those are what we know. Okay, so when theta is equal to 2 pi over 3, we end up with r equal to 1 minus negative 1/2, so 3 over 2. So if this one here was 1/2 pi over 3, now have 2 pi over 3 halfway between 1 and 2. 3 over 2, 2 pi over 3. And so then, once we leave this point at pi over 2, we're going to go out to this one, and then the graph ends up going kind of just like this, and then we can keep checking more angles. But we have some symmetry here, just because cos of theta is equal to cos of negative theta, because cos is even. And so then the below ends are the same. If that doesn't make sense to you, that's okay. You can just do more points. That's fine. But the point is, then we get this cardioid. Beautiful. Another point you can choose is like, just by kind of looking at this graph, we think, okay, well, if this is what happens at pi over 3, what happens at negative pi over 3? Turns out you also get a radius of 1/2, and so on. So hopefully that helps for sketching a cardioid like this. We only got a couple more. And I'm going to just put this in one big video just because it's, I don't know, all in one place. Okay, r is equal to cos theta. This is a nice one. So if this is our normal graph of cos, so this is theta and this was r. Again, we're just going to kind of get some reference points and see what we get. So r's maximum is 1. So if we are to try to do this business with like these radius circles, that one's just a little too sloppy. So this is when radius is 1. We can have that as a little reference point. Let's also have 1/2 as one of them. Okay, so let's see, we've got this point at 1, 0, because when theta is 0, cos is 1. Then we'll have a point at pi 0, or at 0 pi, because we know that if the angle is pi, then cosine is 0. Okay, and then what happens is we just get these points again if we look at 3 pi, or if we, sorry, no, this is pi over 2, sorry. If we look at pi, we get -1 pi, which is the same thing as 1, 0, so that's not useful for sketching, and same with the rest of these main points. So for this one, it's really important that we look at some in-between angles. So let's try pi over 4. Cosine of pi over 4 is √2/2. So let's see, at pi over 4, we get this kind of here. Then let's do some more. Let's say, well, I guess we know that we'll also get then at 7 pi over 4, we'll also get the same point. So like right over here. So this is just translating what we have on our graph to the circle. Okay. A nice one I always like to look at for cos is just pi over 3, because we know then that r is 1/2. So here we can get this point along the r is equal to 1/2 radius reference point. And we'll see if we keep plotting more points, we get this circle. Yeah, like you can have, we did pi over 6, we'd get this point here. And I guess that would be at √3/2, and so on. And you'll see that because cos of theta is equal to cos of negative theta, any point that we get up here, we'll also we can just kind of reflect down there. So like this one here is 1/2 negative pi over 3. And there's our circle. Nice. And if we did check some angles, like all of these angles that lie in this negative part, it would just kind of give us the same points again. Just like how we saw that -1 pi gave us 1, 0 again. Okay, so this one's similar. So here we had cos theta, and now we have 3 cos theta. But if we compare, the graph is exactly the same, except that now instead of a peak at 1, it's at 3. The low point is at -3. But all of the other reference points are the same. And so, in fact, what we can do is we can just take, if we wanted to, we could do this all from scratch. But just because here we're looking at what we have before, we can actually just take those same points and multiply the radius by 3. So, now here we'll have 3, 0. So if I go like this, let's do our radius circles again. Then we've got this one at 3, 0. And then we've got, instead of √3/2 pi over 6, we have 3√3/2 pi over 6. So like, and then instead of √2/2 pi over 4, we have 3√2/2 pi over 4. Everything just gets multiplied by 2. then we've got like, instead of 1/2, this one's kind of messy, I guess. Got 3/2 pi over 3. But it's same as last one, it's just that it's got radius 3. Or radius 3/2 instead of 1/2. In terms of like the size of the circle. Diameter is 3. Okay. We have now radius is equal to 1 plus cos theta. So this is just the graph of cos theta shifted up by 1. So that means then we'll start at 2. Our low point will only be value 0 at pi, and then we are up here at 2 pi. Let's get some more angles. So that means then at pi over 2, instead of being 0, we'll actually have a value of 1. Let's translate this into some points. So we've got 2, 0, 1 pi over 2, 0 pi. We're going to have then also 1, 3 pi over 2. Let's start plotting these. So we got that 2, 0. Then at pi over 2, we've got 1 pi over 2. Then we have 0 pi. And then we've got 1, 3 pi over 2. Now let's choose some more angles in between just to kind of guide us in the sketch. So let's say we choose pi over 3. Then now we have r is 1 plus cos pi over 3. So that's 3/2. So that's halfway between. So that means pi over 3 would be halfway between, something like that. Let's do some more. Well, we know that if we have that one, we'll also have at 5 pi over 3 the same one, because that's the same as like cosine of negative pi over 3. So that would mean like right here. Actually, that's not far enough out. Yeah. Okay, I'll have to erase that, but you know what's supposed to be there. Okay. It's supposed to be halfway between, so something like this. So the radius is 3/2. The angle is 5 pi over 3. Okay. And then we can, do more angles. So let's say we did pi over 6. That should give us 1 plus root 3/2 pi over 6. So whatever that number is here, and so on. So that means then we can see that for this part of the graph, we're going through like this, and then it's going to do the same thing in the bottom part here. Now, for the rest of it, on that left-hand side, these angles between pi over 2 and 3 pi over 2, let's choose some more to evaluate. So let's say we're doing 2 pi over 3. Then normally cos there is negative 1/2, so we just get 1/2. So that means we're like right there. Our curve's going to go like that. And of course, we can do more points to convince ourselves of that. And then for this one, let's say we're doing 4 pi over 3. You'll see that you also get the same radius of 1/2. So that gives you this point here. That's like too close. like there. Because it's supposed to be halfway between the origin. And that radius equals to 1 circle. So here we go. Nice little cardioid. Okay. So this one, r is equal to 2 plus sine theta. This one's kind of a weird one to do because it's not actually one of the same types of curves that we've seen in these previous examples, but I'll show you what happens. Okay, so normally sine starts at 0, but here it's going to start at 2 because we've shifted it up by 2. Okay, so then normally we'll have this point at pi, 3 pi over 2, pi over 2. Let's translate these into some points. This one, angle is 0, radius is 2. Angle is yeah, sorry, I'm just thrown off. I think I sketched this kind of wrong. Let's pretend this is the 1 line. This is 0. Okay. So here, when the angle is pi over 2, we get radius of 3. Angle is pi, we get a radius of 2. This tells us that when angle is 3 pi over 2, we'll get a radius of 1. And then back here, 2 pi. Okay. You can start sketching. So this is our polar axis. Let's say this is radius equals 1 circle. This is the radius equals 2 circle. This is the radius equals 3 circle. So we start at, when the angle is 0, we've got this radius of 2. Then when the angle is pi over 2, we get the radius of 3. So we're on that r is equal to 3 circle. And then when the radius is pi, when our angle is pi, our radius is 2 pi, or is just 2. Then we only have a radius of 1 down here at pi over 3, or 3 pi over 2. And then it's back there. Okay, and then to help guide us with the sketch, we can calculate some more angles. Let's see, so we could do, let's say, pi over 6. When theta is pi over 6, r is going to be equal to 2 plus 1/2. I'll just write 2.5. So that's right here. Let's see what happens when r is 7 pi over 6 as well. So that'll be, okay, 7 pi over 6, that's usually negative, so you actually have 1.5. So that's like 1, 2, so it's like, okay, wait, 1 second. This is a weird one. Okay, wait. 2 plus sine theta. Oh yeah, that's down here. Okay, yeah, cool. But then if we go and look at 5 pi over 6, that's why I was thrown off. Then sine is positive, so we get 2.5 again. Then we could look at such as pi over 3. Theta is pi over 3. R is going to be 2 plus root 3 over 2, whatever that number is. So that could be like here. And point is, we get this shape that's kind of like this. It's supposed to be like a circle that's kind of flattened on the bottom. This, if you compare to the equations of the curves that we're looking at before, this is a limaçon. I still haven't looked up if that's how you're supposed to say it. But yeah, this is a weirder one. It does get kind of flat on the bottom and grow like that. Yeah, we can plot, of course, more of these angles to kind of get a better sense. But that's the idea. Okay, I think we only have like 2 left. Okay, r is equal to 2 plus cos theta. Now, or 2 plus 2 cos theta. This you could also write as 2 times 1 plus cos theta. Now, we know this is a cardioid, so this will just be the same as the cardioid for 1 plus cos theta, which we did earlier, but we just stretch it out by 2. It's just twice as big. But I'll do it from scratch too. Say 2 plus 2 cos theta, we start at 4. And then we're going to go down, back up. Our little midpoint here, that's when we would normally be 0, so that's at pi over 2. The low point is at pi. And here at 3 pi over 2, the radius is 2 again. Okay, let's start plotting out those points. So we have that as our polar axis. I'm going to do these circles again. Good enough. Okay, so 0, get a radius of 4, so that's that. Then when the angle is pi over 2, we saw we have a radius of 2. Then when the angle is pi, we actually have a radius of 0, so that's what this one is. And then when the angle is 3 pi over 2, we get a radius of 2 again. And once again, we're going to have to choose some in-between angles to get a better sense of how we can sketch this. So let's say we do pi over 3, then r will be 2 plus 2 times 1/2, so 3. So that's how we get this point here. So that's at 3 comma pi over 3. And then we'll have the same one over here. So this is at 5 pi over 3. We'll get the point again, 5 pi over 3. So that'll be like right here. We could also write that as 3 comma negative pi over 3, if that helps with the symmetry for you. Okay, what else? We can look at, let's say, 2 pi over 3. Then r is actually going to be equal to just 1. So at 2 pi over 3, we get a radius of 1. That's right here. And then at 4 pi over 3, we get the same idea, where we get a radius of 1. And so if we put this together, and we could, calculate more points, we'll get, again, a very similar cardioid to 1 plus cos theta, but everything's just been multiplied by 2. Great. Yeah, the new thing I'm doing today is adding these radius lines. I find them very helpful for sketching. If you prefer writing things as XY coordinates to sketch, that's also fine. But I really like this method. Okay, now this last one, technically the one on the old exam questions sheet was 2 sine or r squared is equal to 2 sine 2 theta, but that's what your homework question is, so I don't want to do exactly the same one. I'll do it with cos, and then you can kind of use the same strategy. Okay, so what I'm going to do is I'm going to graph just y is equal to 2 cos 2x. I'm calling this x and y just so we don't get too confused. So that's period now of pi, an amplitude of 2. Okay, wait, third time. Okay, good enough. Okay, so period was pi, so we'll go through that there. We have this 0 at 3 pi over 4. This one's at pi over 4. This low point is at pi over 2. So let's start collecting some points, I guess. Yeah, okay. Yeah, so r squared is equal to 2 cos 2 theta. So what we're going to do is we're going to calculate what 2 cos 2 theta is, and then we get 2 different possible radius numbers. So for instance, when theta is equal to 0, r squared is equal to 2. And so then r is equal to plus or minus root 2. Then we've got when theta is equal to pi over 2, r squared is equal to 2 times -1. Oh, so we actually don't get anything there. So here we get -2, so there's no r there. And so for all these ones that are like below the x-axis, we can kind of just ignore them for sketching. Let's only look at the angles above. Okay, okay, here we've got the points root 2, 0, and negative root 2, 0. Let's see, let's get some in-between angles. That's going to help us. As well as, actually, and this negative root 2, 0, this is the same thing as root 2 pi. So we already have one of the solutions for, or one of the points at pi. Okay, like I said, let's use some of those in-between angles. So let's say we're doing pi over 6. When theta is equal to pi over 6, r squared is equal to 2 times, okay, so then sine of pi over 3 is 1/2, so we get 1. So that means that r is equal to plus or minus 1 at theta equal to pi over 6. So that means we get the points 1 pi over 6 and -1 pi over 6, which is equivalent to 1 7 pi over 6. Oh boy. Okay, let's maybe start sort of sketching. So this is our polar axis. Okay, we've got some things that have radius 1. And we've got nothing with radius 2 because we're taking that square root. So let's just kind of call this radius of root 2 because this is kind of in between a little bit. Okay, so we had that 1 pi over 6 here. Then we had this root 2, 0. And then we're also going to have root 2 pi Then we have 1 7 pi over 6. Okay. So we know then at pi over 4, we're going to go back to 0. And then we can't look at any of those angles between pi over 4 and 3 pi over 4 because we get those negative values for 2 cos 2 theta. But then we can start looking at the ones above the x-axis again. So let's say we're looking at 5 pi over 6. And theta is equal to 5 pi over 6. R is equal to 2 cos 5 pi over 3. So 2 times, 5 pi over 3, so that'll be 1/2 again. So we get more that are a 1. So that means we have plus or minus, that's r squared, plus or minus 1 at 5 pi over 6. So that gives us 5 pi over 6, as well as negative 5 pi over 6, which is equal to 1 negative pi over 6, let's say. Okay, so let's put those ones down as well. So we have 5 pi over 6, 1 negative 5 pi over 6. Okay. So the way that this ends up tracing is like this. And this is a lemniscate. And the order in which you do go through the points is determined by the angles, like even if you look at like the negative radius, if that makes sense. But yeah, that's kind of a trickier one, but hopefully that helps you for sketching it, and you can still do something similar then for r squared is equal to 2 sine 2 theta, where we kind of look at these in-between numbers that give you convenient values. I don't know, like that's why I chose pi over 6. Here I would probably choose a lot, because I know the sine of pi over 6 is 1/2. So I'd probably go like with pi over 12 to kind of help with that. And then also some other, I don't know, convenient numbers basically is what I'm going after there. But as long as you're able to kind of visualize where things are, whatever works for you. Okay. Oh, I think was that it? That was it. I have an extra graph for no reason. Okay, well, if you watched all of this, I hope this helped for curve sketching. If you want to have solutions for like the actual final exam answers, I don't know if I'll have time quite yet to fully write those out, but you can always come to me and we can work out what they should look like. But yeah, hope this helped. Enjoy these sketches.